Good day, everyone. I'm excited to bring you yet another topic, beautiful field of electronics. Welcome once again. And today we'll be looking at fixed resistors. All right. So, of course, we all know that there are different types of resistors, okay? There are fixed resistors, there are variable resistors, and of course, there are SMD types. So I'm going to be looking at fixed resistors and their color codes for you to be able to understand them, the SMD types. SMD simply means surface mount devices. Please, if you are joining us for the first time, don't forget to subscribe, like, and share the video. It gives us encouragement to do more of contents like this, okay? So without much ado, let's get right into what we have. If you look closely, I have a number of them here. If you look closely, you find out that on it is inscribed some, colors, and it's good that when you look at the colors, you should be able to combine them in a particular way to be able to tell the value of that resistor. So there are a number of them here. We'll get to look for their values from the color codes, and then we'll confirm with a multimeter to see that what we are doing is correct. Then also we have some surface mount devices, like I told you. Now, if you notice, this is a resistor, this is a resistor, this is a resistor. These are resistors. The black ones generally are resistors, okay? And if you notice also, there are numbers written on them. It will be important for you to see that number and be able to tell the value of that resistor, okay? So let's start with, I think a good place to start from is to show you the arrangement of, the colors. We have B, R, O, Y, G, B, V. Then we have um, uh, gray, and we have white. All right. B, the first B stands for black. The second B is brown. The next one is red. Next one is orange. The other one is yellow. The next one is green. This one is blue. And this is violet. You could call it purple too. Purple. This is gray. And this is white. All right. Now, each of these colors have a number attached to them. Black is 0. Brown is 1. Red is 2. Orange is 3. Yellow is 4. Green is 5. Blue is 6. Purple stroke violet is 7. Gray is 8. And white is 9. Now, once you have this information, you should be able to combine them in a particular way to tell, okay, the value of that resistor. Let's pick a random one. For example, I pick this resistor and I need to know the value of this resistor. Okay. Now, if you also look, you find out that there is another color down always under it. Okay. That color is known as the tolerance. All right. The tolerance. And then most times the colors you find there are silver and gold. We'll get to that, but just ignore that one for now, and then let's get the value of this resistor. Okay. Now, since it starts with red, okay, red, if you look here, is what? 2. You write down 2. It has another red, you write down the value 2. Okay. The next one is what we call the multiplier. So you put a multiplication sign and then write 10. Okay. Then that color is orange. And orange falls into what? Number 3 raised to power 3. Okay. So 2, 10 raised to power 3 is 1000 multiplied by 22 gives you what? So this resistor is a 22,000 ohm resistor. Of course, put it in scientific notation, you have it as 22K. All right, 22 kilo ohms. You see how simple it is. Now let's look at another random one. This one starts with brown, and brown is what color? 1. The next color we have there is green. Green is which number? 5. Then the next color we have there is yellow. Yellow is which number? Yellow is 4. But remember, I said the last one is usually the multiplier. So times 10 raised to power 4. So let's see what that will give us. 15 times 10 raised to power 4 is 1, 2, 3, 4. 1, 5. That's 150,000 ohms. No, this is very wrong. Yes, it is correct. It is correct. So this is what 150,000 ohms or 150 kilo ohms. All right. So you see how simple these things are. Now the next one, we'll just pick another one. This one is orange, and on the chart we have orange to be 3. The next one is white. White is what? 9. Then we have red. Red is what? Remember, times 10 raised to power. Red is what? 2. So this gives us what? 39 times 100, which is what? 3,900 ohms. Okay? And always take it to scientific notation. Okay? So this gives me 3.9 kilo, 3.9, sorry, 3.9 kilo ohms. All right. So orange, white, and red would give me what? 3.9 kilo ohms. So for the ones we did, let's use our multimeter to test and see if our colors are correct. Okay, so with the multimeter, I'll just switch it on. Remember, the first one we tested was red, red, orange. Let's see what the multimeter tells us. The multimeter says it is what? 21.5 kilo ohms. Of course, very close to what we have here. All right. Now, that's where the tolerance comes in. And many times, your tolerance simply means the how different it will look when you measure it, how different the value will look when you measure it. And then gold tolerance is, I think, 5% or 5% tolerance. It simply means that if you look for 5% of 22,000, you can add it or subtract it from that, meaning that when you check it in real life on your meter, what you will see is a value a bit higher than the value that is written on it, by 5%, or a value less than it by 5%. Okay, that's just basically what tolerance is talking about. All right. So we see that this one is, pretty much it. Then the next one is we measured was brown, green, and orange. Let's see. Brown, green, orange. Okay, let's switch it to a higher range. Brown, green, orange. You see, 147.4 kilo ohms, which is, close to 150 kilo ohms. Remember, because of the tolerance, we might have a little bit less or a little bit higher. All right. And that's why you see sometimes they write plus or minus, meaning plus 5%, meaning you can add 5% of that value to the resistance value, or you can remove 5% value to that resistance value to still give you something close to what you have there. Now, the last one we tested, we looked for the value was orange, white, and red. Let's see. You see, it gives us our 3.8 kilo ohms, which is, very close to what we have. And like I said, the explanation to that is your tolerance. So quickly, let's just look at the SMDs. These ones are pretty much easier. So if you look at, for example, let's look at this one. It is written 473. 473 in this case simply means 47 times 10 raised to power 3. You see how easy this one is. So this gives me what? 47,000 ohms, or what? 47 kilo ohms. All right. Now, we are going to use our meter to try to confirm if it is correct. But one thing we should take note of is this: because it's inside a circuit, the value might not be exactly what we have there, but just know that it's a 47 kilo ohm resistor if you take it out of the circuit. All right, but let's just see what value the meter would read. It should read something close to that. Oh, it gives us the value. So you see, it is 47 or 46.9, which is 47, approximately 47 kilo ohms. So you see how simple these things are. So please feel free to ask your questions on the comment section, and don't forget to subscribe and like these videos. This gives us an encouragement to do more of all this. All right. Thank you so much, and I hope you learned something today.